Okay, so please focus because today we can be like talk more about theoretical. So sometimes theoretical part is like not that interesting. Means you guys can get bored, but we will try to get some examples from the real life to make it interesting, to make the stats interesting for you. Okay, last time what we started is the basic probability. Yeah, we were doing the basic probability. We have done the basic probability and learned some key concepts about finding different kinds of probability and probability distribution. Um, these essentially covered three kinds. One, one is the classical approach, means classical probability, where we use the historical data to find out the likelihood of the event. The other one is empirical rule, and the third one is subjective, based on your expertise. You conclude the likelihood of occurring any event, right? So these three are the basic probability, different types of probabilities we usually use to understand these probability distributions, this probability and probability distribution. We need to know some key concepts. So we have also, you also learned about how exactly probabilities functions are, that are to know about what is an event, joint event, mutually exclusive event. We have done all this about the complementary event. So if you just move a bit behind to the slide, so you know, we have covered all these empirical probability, mutually, what is a mutually exclusive event, what is the sample space, what is continuous table, like frequency table, joint probability, marginal probability, conditional probability. So, and then also like addition rule and subtraction rule, sorry, multiplication rule. We have done this in probabilities. So for now onward, you must be really good in that. Like if what is the probability of some event, if occurring of some event given with the information of another event. We have done that as well. That means conditional probability. Then we started to solve some examples. We were in the midway of solving examples. I think we have done some examples, but some examples we haven't done. So let's refresh our mind with the previous concepts, and then we will continue from here onward. For example, this example we have done in the class, and some examples I have asked you to do. I don't know whether you have done it or not, but I'm sure that you have gone through those. Have you? Have you gone through those examples? Like, for example, what is the probability that a student is between age 42 and 49? Who can tell me? So number of n, sum of f is 30. So what is the probability of age 42 to 49 is 3 by 30 means 0.3 means 30%. Yeah, simple. I don't know. It's 0.1 and it's 10%. So there is a 10% that if I pick a student from this class having this kind of age group from 18 to 57, that the student is having an age of between 42 and 49. Understand? So let's take another example. Out of 36 people applying for the job, 20 are men, 16 are women. So we draw the contingency table for that. 8 of the men and Yeah, so 8 of the men and 12 of the women having a PhD. Yeah, like they are doctors. If one person is selected at random, so not everybody, but 8 of the men and 12 of the women means 20. Total 20 are PhDs. Now here is a test for you. If one person is selected at random for the first interview, find the probability that the one chosen has a PhD. So how to do that? Can you do that? The chosen one is PhD. Can you do that? Can you find out the probability from the information? What do you do? You just make a table first, right? And then look. This you need to calculate. So how many PhDs? 20. Non-PhDs? 16. Total PhDs? 36. So simple. 20 by 36. Solve it and you can find it. What is the probability that one chosen is a woman and has a PhD? Now this is like 2. So 12 PhDs from total, right? Woman. So it will be 12 by 36 because total n is 36, so 12. Similarly, you can find out. So if you have drawn the contingency table, it's really easy to calculate rest. What is the probability of a man and not PhD? It's 12 by 36, right? And so on. So what is the probability of a PhD woman out of total women? So among the women, how many women are PhDs? What is that probability? Like if I select only one woman, uh, like I have to select 2 for the job interview. There is one male and one female. So for female, how many chances are there that the female which I now this is one is fixed, right? I have to select female. So I will see only this one sample size. Now my n changed. So now the n is 16 instead of 36. So what is the probability of the woman which I selected for the job is like PhD. So it will be 12 by 16 means there is really high possibility that the woman I will select is having a PhD degree, and so on. So do you understand this? Now, what is the probability that one chosen is a woman or has a PhD? That's very simple. We have done this. Now, there's another example. Let's take a look. Of the 20 television programs to be aired this evening, Mark plans to watch one. So in today's evening, there are so many TV programs, but Mark plans or you plan to watch one. Which will you pick at random by throwing a dart at TV schedule? If 8 of the programs are educational, 9 are interesting, and 5 are both educational and interesting, find the probability that the show you will watch have at least one of these attributes. Which attributes? The probability that this one. So if E represents educational and I represents interesting, then probability of E is how many? 8 educational out of total program. So total program is 20. So 8 by 20, that's right. That PI is this. What is PE and I? So now here you will see that what we have learned about intersection, how to get probability of E, A intersection B, which means common, right? That both interesting and educational. So we always use and means addition, right? So probability of 1 plus probability of 2 minus probability of what is common. So what is common? How many are common? 5 are common. So that's how we calculate. probability of E or I. Do you understand this one? Now, if you understand this one, let me ask you to calculate this thing. The probability that a person selected at random did not graduate from high school is 0.25. Now, this is probability given, right? So probability is given of not having graduate. If three people are selected at random, find the probability that all three do not have a high school diploma. Can you find that? Hmm? Each person is independent because they have nothing nothing common. So probability of all three do not have high school diploma can be like this. This is number of outcomes. That's 20.25 probability and times power 3. So all three have a high school diploma because remember, they are not dependent on each other. They are independent. They didn't say any information of being dependency. All three having is like 0.753. At least one has high school diploma. Can you find this? At least one has high school diploma. So it will be 1 minus none have high school diploma. So none have high school diploma is this means at least one have high school diploma. Do you understand how to calculate this? As I said, like P is an event happening at least one is 1 minus is here I use the complement law of complement, right? Probability, complementary probability. That 1 minus the complement. If complement is like at least if the probability is at least 1, so probability the complement will be none, right? Because other than none includes at least 1. That's why. So let's take a last example and then we go forward. The worldwide insurance company found 53% of the residents of the city had homeowners insurance with the company. Of these clients, 27% also had a car insurance within the company. If a resident is selected at random, find the probability that the resident has both homeowner and a car insurance with this company. So can you find out? So both again and so I give you 2 minutes to find out. Can you? No? Okay, this is given 53%. Now you just simply have to get A and B because it's like a conditional probability, concept of conditional probability that one is given and you have to get another one. So both homeowners and car insurance in the world. So A and B here is like a probability of the residents who are owing the home insurance times the probability of car residents owing the car given that they have also homeowner residence. So simple, just times multiply because both are given. I don't know if you have remembered this one or not, but you have to. I think it's you must keep in mind this phenomena of conditional multiplication rule. This one. The probability of two events, if A and B will occur in a sequence. So here there was a sequence. Yeah. So some residents have homeowner insurance, some residents have car insurance, and we have to select the both. So that's how we differentiate that they are dependent because they are the same residents. They're not independent. So in case of independent, we will just do different. This time multiply the same insurance, different insurance, right? This one is given, so it's easy. Now, let's start today's lesson. And so this example, you should practice more example from the book because it will be the part of the quiz next week. Today we will continue and start to learn about random variables. What is random variables? But so far we have discussed that. Yeah, I can use this. Look, there are two important concepts: random variable and fixed variables. Fixed variables are like constant; they cannot change. I mean, they don't change over the time. But they are variable, but they don't change over the time. They're fixed in nature. Whereas random variable is random because there are certain probability distribution associated with them. How? What is this concept? Let's talk in details. So, as you can see, a random variable x represents the numerical value associated with each outcome of each of a probability distribution. So that's the main theme. If we explore or try to understand this theme, I can say that we have discussed so far basically the probability that if total space is given, then how we get the likelihood of occurring one event from that sample space. Yeah. So total sample space is given, and what is the occurrence probability of having event, which is a part of this sample space, A, B, C, so on. Yeah. So A is a subset of this, and what is the probability? That's what we have learned so far. If we go further and take an example, for example, if I toss or flip three coins, so what is my sample space will be? What my sample space will be? So can you find out that what will be my sample space? Let's see. So three coins means how many outcomes? And times of experiment. So we have done this experiment 3 times. So in head and tail, the outcome are only two, head or tail, right, in a coin. And we have repeated it for 3 times. So it must give has 8. So there are 8 possible sample space by flipping a coin 3 times, by doing the experiment, by repeating the experiment 3 times. What are the possibilities? We can have had 3 heads. That's one possibility, right? Or 2 heads and one tail. Now understand this carefully. That's why I'm just writing it on the board as well. And first one, last tail, head, tail, head. This is another possibility. First head, second tail, and the third one is head again. Or first tail, second head, third head, right? And keep moving, and you can find out like then we can have first tail, 2 heads. No, there is another option, right? Before this. First head, two tails. That's another possibility. Um, First tail, then head, then tail. Am I missing something? So three heads, head, head, tail, head, tail, head, and tail, head, head. So similarly, you can have tail, tail, head. Yeah, that's head, tail, tail. That's tail, head, tail. Then this is tail, tail, head. And then this is can be tail, tail, tail. So these are the 8 possibilities. Can you have like more possibilities than these? No, we can't. This is our total sample space. Now, among these 8 possibilities, we can say this is our sample space. Now, question is, how do we know is that in a coin, how many possible outcomes? Simple, 2, head or tail. So flipping the coin 3 times, we can get this sample space 8. Similarly, you can say if I have like 2 dice, so how many is a sample space of rolling the dice die 3 times or 2 times? So simple. What are the possible outcome of a die? 6 outcomes, right? 1, 2, 3, 4, 5, 6. And because how many of time we are repeating the experiment twice. So it give me 36. So if it's 3 times, then 36 times 3, I think it's 256. But at the moment we are, let's take example of this one and try to figure out that what does random variable means. So we have like total sample space, right? So if I ask you what is among those head, 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 tail, head, tail, head, tail, tail, tail. Oh, sorry, tail, head, head. So this is one, and similarly tail, 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 and so on. So these are 8. So now among these possible possible sample space, what is the probability of 2 heads? You can easily find out. Total is 8, so we can draw the distribution, whereas x is number of heads. It's a random variables. It changes. It changes over the time. It's a random variable. We'll see what is it. So what is the possibility of x means 2 heads? So there can be 0 head, there can be 1 head, there can be 2 head, and then there can be 3 head. So the possibility, oh, so I can just say, now you know the sample space, I don't need to repeat it, right? So there can be 0 head, there can be 1 head, there can be 2 head, there can be maximum 3 head, because we repeated the experiment only 3 times. So what is the possibility of having 0 head? There is a 1 possibility out of 8 is 0. How many of 1 head? 2 or 3? Tell me. So 3. On 2 heads, 3. And 1, 0, 3 heads, 1 by 8. So what is this? This we know as a probability distribution and probability distribution of x. Now let me explain you what exactly that means. If we are asked to make a probability distribution, it means that we have to represent the sample space. So we will represent the sample space with the numeric number, which is in this case head. What is that numeric number? Like here in this example, we have 3 times head, 2 times head, and 0 time head, 1 time head. That's the numeric number, 0, 1, 2, 3. Hence, numerical value associated. That's why I said numerical value associated with each outcome of a probability distribution. Whatever sample space is, we are performing. Now, in probability distribution, we take the value against each random variable. So these are the random variables, and we take a value against each of them so that we can define random variable x is a function of a function from the sample space to r. R is a random variable such that means that is it belongs to r. For each outcome w, it belongs to total sample space. In simple word, xw means is to be a number of heads in our example. Do you understand? In outcome w. So if we need to represent this example with random variable, we can draw this. X is a random variable. Now, if we take the probability, which we have done, of every event against every event, then it is probability distribution. So we can say if we take the probability of every event against that event, it's known as a probability distribution. And you know, the sum of probability distribution is always 1. And if we do sum, it should give us the 1. And we can define if we arrange our random variable value with respect to their corresponding probabilities. That is called probability distribution. So what is probability distribution? That's right. Sorry, I have to fix it. So just need to fix it. You see, so that's the same example. We have done it. So the corresponding probability, I can define random variable. Let me define it here. I repeat, if we arrange our random variable values like 0, 1, 2, 3 with respect to their corresponding probabilities, that is called a probability distribution. Same as we define the frequency distribution. You will see it's like have a quite of similarity with the frequency distribution, the probability distribution. In frequency distribution, we were arranging our classes, our groups, our variables according to their corresponding frequencies, right? So here, random variable is associated with the numerical value that is corresponding according to the sample space, and probability distribution is against the corresponding value of probability. Now there are two types of random variable. So this probably, I hope this you understood. So mathematically you can define it. Mathematically you can define it in this way. Example is the same example. So possibility of 0 head, 1 head, or 2 head, or 3 head, you can find out by drawing the sample space. Mathematically, you can say define random variable X is to be random variable to be number of heads in an outcome of W. Now this W is an outcome of this which belongs to the sample space. So this is the event, and this is the value. X is a value from that event, right? So number of head is from the event of having head. Do you understand that? So if this is W is this, then what is the random variable? It's 2. And what is the probability? Is this, you can say 3 by 8. Do you understand? Let's move forward and see how many types of random variables and what does that mean. So we have already learned a basic about this. Now let's see with the probability rule. So of course there are two kinds of variables, which means discrete and continuous. So also random variables should also be two kinds, right? Two types. That is discrete and continuous. One is discrete. What is discrete? Countable. So discrete is a countable. So it is a countable set, for example, n is 0, 1, 2, and so on. Or in case of any two event outcomes, it will be 0 and 1. Whereas continuous, when we talk about continuous, it means that the variable is continuously moving in the range. So continuous belongs to a range, right? So for example, we integrate in the range. It means that if I say that the function is lying between range of 1 or 0 and 3, so it moves uniformly up to 3 with at a certain value. So it's not like a curve, it's just a straight line up to 3, and from 3 onward it has different value, so then it can be this. So that's how we graph like the continuous variable. We will talk more in details later on, but let's first understand the discrete probability, discrete random variable. It is number from any number from 0 to 1, which is countable, which is not like within a given set of continuous. Unlike the continuous, these are countable, and the probabilities against it are the function. Function means probability mass function. Just we built in last slide, that is probability of X, this one. To make mathematical function, we can given it as probability of X belongs to A, which is an event, whereas an A belongs to the sample space. Now remember, sum of probabilities within a given set is always equal to 1, right? So I can draw probability mass function as we can denote it with p of x. Some also denote it with only f of x. You can do both, where capital X belongs to small x is small x, and x belongs to A, which is sum of probabilities of x. We will take a more deep look into that later on. Similarly, in continuous random variable, we call it probability density function. So in discrete, we call it probability mass function. For example, if we are given with the same example, if we take x is 0, 1, 2, 3, and probability of x is this, then the probability mass function is sum of probability which only belongs to A, like 2 heads, minimum 2 heads. So 2 heads can be 3 by 8, right? In this way. We draw it like, we make it like sample, and then we draw this, and same thing we are doing here. Whereas in continuous, the given range is there. That's why it's known as continuous. And we call it probability density function, and it lies under a certain range. Hence, in probability mass function, we add, but in probability density function, we are integrating the function. Why? Because integration also means adding up, but within a given certain range. Another function which we will discuss is distribution function, but we will focus more it in later lectures and later slides. But first, let's see a little in terms of discrete probability distribution. We will also discuss few of special probability distributions in discrete way in this course. But remember that whenever we are talking about probability mass function or probability density function, even if it's a discrete random function or a continuous probability function of a random variable, we have these 3 properties which should be fulfilled. We'll talk about the properties later on. But this is the way mathematically we can see the distribution described by probability density function is like f of x. You can also denote it with the same p of x. You need to differentiate the main function, the frequency function, means integrate it, and then integrate it. It's mean minus infinity to x and mu du. What is this distribution? We will talk later on. But here we have a range. So we can say probability distribution, a random variable, is a function that assigns a real number to each outcome in sample space. That we know the probability distribution of a random variable x gives the probability for each value of x. That's also sure. So these are the 3 properties of a probability mass function. Even it doesn't matter if it's discrete or if it's continuous. What is that? One, if x is a random variable and which there are x1 to xn values which are indicating the values of random variables, then against every value of x equals small x, this one, then x equals, the probability mass function should be positive. That's one. So it means, and you should remember that it should not be greater than 1. So you can say it lies between probability of x equal to x, small x. You can also say f of x should be equal between 0 and 1. Second, sum of probability always equals to 1. That you know, so no need to elaborate this one. It means it covers 100% of the data. Thirdly, we can write the probability in terms of, as I told you, p function of x can be written as this one. So these three properties are of probability mass function. Now let's talk about cumulative distribution function. Maybe you have remembered that we have done already about the cumulative frequency distribution. So it's a similar concept. Cumulative means you need to add up second one into first one, second one into first one, and then you can get the corresponding value. Let's talk about cumulative frequency distribution after the break. So now we can have like a short break of 5 to 10 minutes. Then we will continue after it. So meanwhile, if you have any question, please share with me and I will share the screen.